Hello, ladies and gentlemen. Welcome back to math. Today, we're still going to continue working with radicals. Okay, last class, we had radicals that we had to simplify, we had to factor out, so we had to reduce. They were not only numbers, but they also include variables. We had to factor out for squares, for square roots. Today, we're going to cover kind of the same thing. The only difference is today we're going to start doing some binomials and some trinomials, okay? We're not really going to worry about the variables today. We're mostly going to worry about the numbers. So, the one we're going to do today is, for the example, is if we have radical of 40. But, like I said, we're dealing with binomials to begin with. We also have this other radical that has 60, okay? We're trying to see if we can combine them, okay? What we're going to do is we're going to reduce them as much as we can, like last class. We're going to break them down. Two numbers that give us 40, okay? We can do 2 and 20, that's fine. I'm going to do a little simpler one. I'm going to do 4 and 10. Okay, 4 times 10 is 40. If we can break down the numbers even further, go ahead and break them down, okay? So the 4, there's two numbers that can give you 4. 1 and 4 doesn't really work. If you end up with a number like that, where it's 1 times the number, don't break it down anymore, okay? If you have other factors for it, then go ahead and break it down. So here we have 2 and 2, okay, because 2 times 2 is 4. For 10, okay, I like to put a little decimal, let's do a little time so you guys know what we're doing. For 10, I'm going to use 2 and 5, okay. Since there is no number on the outside of the radical, that means that we're looking for pairs of 2's. Okay. Before we break down this one, let's completely finish this one. Okay. Notice that I have a pair of 2's. There's no other 2. There's no other 5. So this 5 and 2 are left over. Okay. Remember, whatever left over goes inside the radical. The pairs go outside. When it comes to pairs, there's no longer 2 and 2. Okay. It's just one pair of 2's. Okay. Just 1, 2. So the 2's become 2 radical of 2 times 5, which is back to 10, right? So we leave it as 10. Plus, now let's break down the other one. Again, 60. There's a few numbers you can break it down to. I'm gonna pick 6 and 10 again. Okay, simple numbers. We have a 6. We have a 10. Two numbers that give us 6. We have 2 times 3. For 10, we have 2 times 5. Okay. Notice that, again, there is no number on the outside. That means, again, we're looking for pairs of 2's. Notice that we have a 2 here and a 2 here, okay? That's still considered as a pair, okay? Doesn't matter if one's in one set, one's in the other. You still have a set of 2's. So again, we can put a 2 on the outside. Since there's nothing else, we can do the radical. Again, we have a 3 left over and a 5 left over. So 3 times 5, 15. Okay. Since the radicals are not the same, you cannot combine them. Okay. Only if the radicals are the same. Think of when you're adding and subtracting fractions. You can only combine them if they are the same denominator. The same with the radicals. You can only combine them when it's adding and subtracting if they are the same radical. Okay. If you're multiplying and dividing, that's a whole other story. But for adding and subtracting, your radicals have to be the same. Okay? We're going to do one more example. Okay? Where it works out to that. Make sure you write down the notes. If you need to pause the video, go ahead and pause it. Alright, so now that you have it, let's go ahead and do another one. Just for the practice of it, just so you guys can see how it works out when you have a few common stuff, okay? So the one we're going to use is, this I'm going to use the trinomial, okay? The one I'm going to use is 3 radical of 2 plus radical of 50 minus 4 radical of 8. Okay? Let's use another color here. Let's go with this color. Alright, notice that on the very first one, you can't really do anything to it because the radicals already simplify as much as you can. Okay, the only other number is 1 times 2, which doesn't really work. So we really don't have to do anything here. So let's move on to the next one. 50. 50, there's numbers I can reduce by or factor out by. I like to use simple numbers. I'm going to use 5 and 10. Okay. 5 cannot be reduced anymore because remember, it's a prime number. The only factor is 1 times 5. It doesn't really work. But 10, on the other hand, you can reduce 10. 2 factors that give you 10, guys. Anybody? 2 and 5, right? Again, notice that there is no number outside the radical, so we're looking for groups of 2's. Do you see any groups? We do, right? We have a group of 5's. So we can write it as 5 radical of whatever is left over, which in this case is the 2. We bring down our other one, since it's positive. We have 3 radical of 2. And then finally, can we break down that 8? We can, right? 2 factors give us 8. 4 and 2. Again, 2 numbers give us 4. 2 and 2. Again, we're looking for pairs of 2's, since there's nothing there. So we have a pair of 2's, okay? When you have a number on the outside already, okay, and you're going to bring out this 2, you're going to multiply both numbers. So you have minus 4 times 2, okay, which 4 times 2 is 8. And then we have a radical of whatever's left over, which is a 2. Okay? So we can say 3 radical of 2. Notice how they're both radicals of 2's. So we can combine them. We have 5 plus 3 is 8. Radical of 2. Okay? The reason why, okay, is because remember, you can combine them only when you have the same radical. So we have 8 radical of 2 minus 4 times 2 is 8 radical of 2. So 8 radical of 2 minus 8 radical of 2 is, any suggestions, guys? 0, right? There's nothing there. Cancels out. So your answer is 0. See how some of them you don't have to break them down. Some of them you do. Some even when there's already a number on the outside and you get a new set or a group, you have to multiply it times the number that is already there. Okay? Once you have the same radicals, you can start combining. If they are different, then they cannot be combined. Okay? Again, think of when you're adding and subtracting fractions, they have to have the same denominator. The same for radicals. When you're adding and subtracting radicals, you have to have the same denominator. Okay? Make sure you write this one also on your notes. If you have any questions, make sure you ask a question, guys. Don't be afraid. Don't hesitate to ask the questions, guys. That's what I'm here for. I'm here to help you guys out. All right, now that you guys have it down, your problems for today are the first one is 25 plus radical of 25 plus radical of 36. Okay? Very, very simple. Hint, hint. All right, for your second one. You have radical of 20 plus radical of 125 minus radical of 45. Okay? Remember, guys, only if you can reduce them to the same radical, you can combine them. All right, so here's your two problems for today. Make sure you send me your answers as soon as you're done watching the video, and I'll be waiting for your email.